biopower. We're offering a environmentally friendly solution for the future. Today, we stand at a critical juncture in history. Climate change is no longer a distant concern. It's here, affecting every corner of our planet. Scientists have long pointed to fossil fuel as a primary culprit, releasing greenhouse gases that drive global warming and threaten our ecosystem. Among the most significant contributors to this crisis is transportation, a sector deeply embedded in our daily lives, but also one with immense potential for transformation. In this presentation, we will explore innovative, actionable solutions to reduce the environmental impact of transportation. Our goal is not just to understand the problem, but to inspire meaningful change, because the future of our planet depends on the steps we take today.
Conventional fuel problem. Fossil fuels take a toll in the environment. They cause obvious problems such as oil spills and smoke-filled air. They also cause other problems that are not so easy to see, acid rain, for example, caused partially by sulfur in fossil fuels, damages buildings and harms streets, aquatic life, and insects.
Global stock shortage. The world today is heavily reliant on fossil fuels, particularly oil and coal, to power our modern civilization. However, global oil reserves are dwindling, and the future without these resources is rapidly approaching. Imagine a world without gasoline to fuel transportation. Supply chains would collapse and global trade would grind to a halt. Without coal for electricity, cities would face blackouts, industries would shut down, and essential services would falter. While renewable energy sources like solar and wind are promising, they are not yet sufficient to meet the global demand. This energy dependency poses a critical challenge to economic stability, requiring urgent action to transition to sustainable alternatives. But the path forward is complex and will take time.
Why algae biofuel? Microalgae has fast growth rate, higher biomass production potential, and can use non-freshwater stream as substrate. Also, the chemical composition in microalgae can be modulated by varying cultural conditions for higher lipid growth. The oil content in some microalgae can exceed as high as 80% by dry biomass content. Microalgae oil also have less emission and less contaminant compared to the petroleum-based fuel. And it also requires non-arid land for cultivating, and it can be harvested daily. But what are algae? They're simple plants that range from microalgae to large seaweed such as giant krill, and they can grow in brackish or sea or wastewater, which are unsuitable for cultivating agricultural crops. Also, they mostly grow through photosynthesis by converting sunlight, CO2, and few nutrients into biomass.
Now, I will talk about material and the method. Let's get working. First, I will isolate green algae species from fresh water. After that, I do morphological and molecular identification of the tested algae species to know the origin of the species. After that, optimization of growth condition of the tested algae species through the many parameters like intensity, temperature, carbon source, nitrogen source to enhance the growth of green algae species. After that, selection of the most promising species, biochemical characterization of algal biomass, and extraction of lipid content of algal species. After that, we can do GC mass analysis of the lipid content extracted from algal species. After that, conversion of algal oil using a different technique in order to obtain biofuels through transesterification process. And after that, we can talk about pilot scale production of biofuel using the photobioreactor. Conclusion: our aim is to utilize green algal species as a source for biofuel production.